Welcome to this tutorial on creating a simple Tic Tac Toe game interface using the Dear ImGui library in C++. In this video, we'll guide you step by step through building an interactive grid, handling user inputs, and adding game logic. First, let me show you the final output of this example tutorial. By the end of this video, you'll have a fully functional Tic Tac Toe game interface. We'll start by setting up a 3x3 grid using ImGui buttons, where each button represents a square on the Tic Tac Toe board. The layout will be configured to ensure the buttons are evenly spaced and visually appealing. We'll start by setting up a 3x3 grid using ImGui buttons, where each button represents a square on the Tic Tac Toe board. The layout will be configured to ensure the buttons are evenly spaced and visually appealing. Once the interface is ready, we'll add the game logic to check for a winner. This will involve evaluating rows, columns, and diagonals after every move to determine if there's a winner or if the game ends in a tie. If a player wins or the game ends in a tie, we'll display a pop-up message showing the result. Additionally, we'll include an option to restart the game for a fresh start. As a bonus feature, we'll track the number of wins for each player and display the scores in the interface, adding a competitive element to this simple game. Now, let's start from the beginning. First, let's visit the GitHub repository for Dear ImGui. To get started, we need to clone the repository. I'll be downloading the main branch, not the docking branch. The docking branch is excellent for building GUIs with docking capabilities. If you're interested in exploring that, you can clone the repository, build the code, and experiment with it. However, for this tutorial, we'll stick to the main branch. Let's download the zip file of the main branch and extract it into a folder. I'll be downloading the main branch, not the docking branch. Open the ImGui master folder and navigate to the examples folder. Here, you'll find a variety of examples for different platforms such as Mac OS, Android, OpenGL, Windows, and more. First, let's open the ImGui examples.sln file in Visual Studio. If your SDK needs to be updated to a newer version, Visual Studio will prompt you. Simply update it if required. In this video, I'm using Windows with DirectX 12, so I'll select the corresponding project as my startup project. To do this, change the startup project to the one that matches your platform. If you're using a different platform, select the relevant project, build it, and run it. Once the build is successful, running the project will display a user interface with several UI components. If you want to learn more about how these UIs work, you can search for their label names in the code to see how they are rendered and implemented. I won't dive deeper into these UI examples in this video. However, if you'd like a detailed explanation of these UIs, including how to use and customize them, let me know in the comments and I'll create a dedicated video on that topic. Let's start from scratch. I'll create a new C++ console project and name it Tic Tac Toe, specifying the file location before creating the project. Now, we have a simple console application. Next, open the ImGui example project and check which files they use for their build. You'll notice some ImGui header and source files are included. Let's copy these files to our project location. Inside the ImGui master folder, you can find these files. Copy them and paste them into your new project location. There are also some OS-specific files located in the backends folder inside the ImGui master folder. Since I'm using Windows with DirectX 12, I'll copy the required backend files, specifically for Win32 and DirectX 12. Paste these files into your project location as well. Now, open your project and import the existing files you just added into the project. Next, go back to the example project, open the main.cpp file, and copy all its code. Paste this code into your Tic Tac Toe game's main C++ file. Let's build the project. If you encounter a missing file error, check the main branch folder of the ImGui project. For example, you may have missed the inconfig.h file. Copy this file into your project location and import it into your project. Build the project again. This time, the missing file error should be resolved, but you might encounter a reference linking error. To resolve this, open the example project's properties, navigate to linker input, and check the additional dependencies. You'll see a list of DirectX library files. Copy the names of these dependencies. Now, open your own project's properties, go to linker input, and add the copied library names to your additional dependencies. Build the project again. This time, the build should succeed. Run the project to verify. Great! We've successfully built the ImGui project without relying on the example project. Now, let's begin coding our Tic Tac Toe game from here. Now, we no longer need the example project, so let's close it. When we run our project, you'll notice it starts with a console window because this is a console application. However, I would like it to open directly as a window without the console. To achieve this, we need to change our main function to winMain. Replace main with winMain. You'll see that winMain has specific parameters. Let's check the required parameters. Copy the parameter list and use it in our winMain. We don't actually need these parameters for our application, but they must be included to match the function signature. Now, let's build the project again. This time, a linker error occurs because our application is still set up as a console app. To fix this, open the project properties, navigate to linker system, and change the subsystem option from console to Windows. Apply the changes and click OK. Let's run the application again. Now, the program opens directly as a window without displaying the console. First, let's change the window size to a width of 400 and a height of 500, and update the window title to Tic Tac Toe. We'll create a new extended window handle and comment out the existing one. Modify the window class information by setting class name to Tic Tac Toe Game. We'll define the extended window style and provide all the necessary parameters for the new window. Set the extended window style to overlapped window and topmost. Assign the LP class name as Tic Tac Toe Game. Set the window title to Tic Tac Toe. Define the window style with overlapped window, minimize box, maximize box, and system menu. Set the window starting position to X to 700 and Y to 300. Specify the window size as width to 400 and height to 500. Set the owner window handle, child window identifier to null. And set application instance handle to wc.h instance as appropriate. Let's set the window opacity and transparency. Use set layered window attributes to set the background color to black, opacity to 0, and enable the color key with ULW color key. Build and run the project. You'll see the window opens correctly with the specified settings. Now, we can start creating our game UI. First, let's remove the default example UI. There are 3 sections in the code where the example UI is defined. Identify and remove those items. Once done, run the project again. You'll see the window now has an empty space, ready for customization. Between the ImGui new frame and ImGui render methods, we can begin building our custom UI. Let's add a new window frame using the ImGui begin method. We'll give the frame the nameplate Tic Tac Toe and set the other parameters to null. Make sure to close the frame using ImGui end. Run the application, and you'll see that the window is created. However, it currently has default behavior. To refine the behavior, let's add some window flags such as no move, nor size, and no collapse. These flags will ensure that the window cannot be resized, moved, or collapsed. Now, the window is static and cannot be resized or moved. However, its size is still carried over from the default configuration. Let's set a custom window size to take up all the space available in the main application window. To do this, use ImGui set next window size and provide the desired size as an im vector 2. For this example, let's set the width to 400 and the height to 500. Run the application again, and you'll see the window size is updated. However, the window's starting position is not yet aligned to the top left corner. To fix this, set the position using ImGui set next window POS and specify the coordinates as 0, 0. Run the application once more, and now the window is perfectly positioned and sized. Let's add some buttons inside the new window. The ImGui button. First set button label, set it as X. Then set button width and height to 100. Add 2 more buttons like this. When you run this, you'll see the buttons are displayed in a row, one below the other. However, there's an error because the buttons have the same label. In ImGui, the button label acts as its unique ID, so duplicate labels cause conflicts. To fix this, let's assign unique labels to the buttons and add more of them. You can see the all buttons display as in the new row. What we need are the 3x3 buttons grid. Next, we'll create a 3x3 grid of buttons. To do this, we need to calculate the starting positions for each button. Let's start by changing the cursor position for the first button. When you run this, you'll notice the button shifts down but still overlaps the title bar. This happens because the position is relative to the top left corner of the window, excluding the title bar. To fix this, adjust the Y position to something like 30. Let's calculate other buttons' positions as well. Manually setting positions for each button can become tedious. Instead, we'll use nested loops to calculate and generate the grid dynamically. Comment out the manually created buttons. Define these variables. For buttons size 100. And for space between buttons set it to 10. Since the grid has 3 rows and 3 columns, use nested for loops to generate the grid. Calculate the X and Y positions for each button based on its row and column. Let's calculate the X position of the button. XPOS is equal to the column number multiplied by button size plus space. And Y position of the button YPOS is equal to the round number multiplied by button size plus spacing. Let's set the cursor position to XPOS and YPOS. And now set the button size, with the button label as X. When you run this, you'll see a 3x3 grid. However, the grid isn't centered properly. Add offsets to align it better. Add 10 to X position and 30 to Y position. Now grid button is OK. To eliminate label conflicts, assign a unique ID to each button using std string. To do that, add the iostream and string libraries to the project. Create a unique label for each button using string interpolation. Create a new string variable for the button label. Set it like this as unique ID. Give that button label to this button. Now each button has a unique ID, but the labels appear on the buttons, which we don't want. To hide the labels while retaining their IDs, add 2 hash marks to front of the label. This way, the IDs remain unique without being displayed on the buttons. If we add some text before 2 hash marks, that text will display on the button. This way, buttons can have unique IDs while showing the same or dynamic labels. To implement the Tic Tac Toe game logic. To define the game board. Create a global char variable to represent the game board as a 3x3 array. Initialize it with empty spaces to represent empty cells. To store current player. Add a global child variable to track the current player. Initialize it to X to indicate player X starts the game. Update button labels to display board values. Modify the button labels to reflect the current value of the board at the respective row and column. Use std string to combine the board value with a unique ID. To handle button clicks, check if the button is clicked. Verify if the cell is empty, and update it with the current player's symbol. Then toggle the current player. If it's X, change to O, if not, change to X. When you run the program, buttons will display the corresponding value from the board array. Clicking a button will update its label with the current player's symbol if the cell is empty. Once clicked, the cell cannot be changed again. This sets up the basic functionality for our Tic Tac Toe game board. Now we need to check for a winner. If there is a winner, the game board will reset, and the game will start again. To check the winner, we'll add a function named checkWinner that will return a Boolean value indicating whether there's a winner. Let's implement this function. The function will check for winning patterns in rows, columns, and diagonals. If no winning pattern is found, it simply returns false. First, let's check for rows. Iterate through each row and check if all three elements in that row are equal and not an empty space. If they are, return true. Similarly, iterate through each column and check for the winning condition. Finally, check both diagonals for a winning pattern. Let's use this function in the game loop. After updating the board matrix, when a button is clicked, call checkWinner. If there is a no winner, update the current player. Let's run the project. You can see there is a winning pattern. After there is a winner, we cannot change the current player. But it's still a change. That's an error. Let's check the function. Initially, the diagonal check conditions were incorrect. The checks for diagonals should ensure the cells are not equal to an empty space, not that they are equal to an empty space. We'll create a new global variable named GameEnded to track whether the game has ended. Initially, set it to false. When a winner is detected, we will set GameEnded to true. If GameEnded, let's add new pop-up dialog to indicate the winner. Set window title to Game Over. And set the window size, width of 200 and height of 150. Begin the pop-up modal Game Over with always auto resize flag. Inside the pop-up window, add a button to reset the game. Label the button as play again. If the button clicks, pop-up window need to close. Don't forget to set the end pop-up. When play again button clicks, we need to reset the game board. To do that, let's implement the reset game function. To reset the game state, implement the reset game function. In the reset game function, need to set the board back to its original state. Let's set the original empty string to all its elements. Also set the game ended to false. And set the current player back to X. Add the reset function when play again button clicks. I need to display some text in the pops-up window. Add the ImGui text and some display messages. Inside the pop-up window, let's show the winner message. Let's run the project. You can see that when there is a winner pop-up window appears, and when click the play again button we can play the game again. Now, let's display the winner inside the pop-up window. First, add a new global string variable called winner message. Next, update the check winner function to set the winner's message when a winning pattern is detected. For rows, we can set the message like this. Similarly, update the logic for columns and diagonals to set the winner message. Once the winner is determined, we'll display this message inside the pop-up window. Using the ImGui text function, we'll show the winner message dynamically. Finally, when you run the project, you'll see the winner's name displayed inside the pop-up window whenever a player wins. Next, let's add a winner count to track how many games each player has won. Start by creating two new global integer variables, xwins and owins, both initialized to 0. In the check winner function, increment the respective variable based on the winner. If the winner is player X, increase xwins by 1. Otherwise, increase owins by 1. Make sure to include this logic in all the winning condition checks, and don't forget to use the correct board positions when determining the winner. After the button grid, add a text box to display the current winner count. We'll show player X's wins and player O's wins using the ImGui text function. Now, when you run the project, you'll see the winner count displayed correctly, updating every time a player wins. Now, let's handle the game tie scenario. After checking all the winning pattern inside the check winner function. First, create a local Boolean variable named isTie and initialize it to true. After checking all the possible winning conditions, iterate through the board to see if there's any empty space. If an empty space is found, it means the game isn't over, so set is tie to false and break out of the loop to avoid unnecessary checks. If it's not tie, break the for loop, no need to check others. Once the loop is complete, if his tie is still true, it indicates the game has ended in a tie. Update the winner message to display, it's a tie, set game ended to true, and return true. Additionally, for better reliability, make sure to set game ended to true right after checking for a winner. Now, when you run the program, you'll see that the tie case is handled correctly, alongside all the other updates. The current font size feels a bit small, so let's scale it up. Before creating the buttons, we can adjust the font size for the current window by setting the window font scale to 1.5. After applying this change, you'll notice that the font size is scaled up appropriately. Next, let's see how to change the default font in ImGui. This process is straightforward. First, obtain a font style file in TTF format. You can download any font you like, but for this example, I'll use a font already available in the ImGui library folder. Copy the file to your project directory and add it to your resources. The relative path to the font file will be just its file name since it's in the project folder. If your file is elsewhere, provide the appropriate relative path. Before applying the new font style, we should add the default font back into the configuration. This ensures compatibility and a fallback option in case the custom font isn't loaded. Now, to load the new font, use the Add Font from File TTF method. Specify the file path, font size, and additional configuration options. For font size, I use 18.5. If you're working with specific languages like Japanese or Chinese, you can provide additional glyph ranges for those characters. For this example, since I'm using standard characters, I'll keep it simple and set the additional parameters to null. After loading the font, it's a good idea to verify that it loaded correctly. If the font fails to load, you'll need to debug the issue. Once the font is successfully loaded, push the new font to ImGui using the push font method to apply it. Run the app to see the updated font. You can see encounter a debug error. It's likely because we forgot to pop the font. Ensure you call pop font before ending the window to revert to the previous font state. Now, everything works perfectly, and you'll see the updated font style applied to our application. Our Tic Tac Toe game is now almost complete. It's time to release the project. To begin, go to the project settings and change the configuration from debug to release. This ensures the final build is optimized for performance. Next, update the linker system settings. Under the subsystem option, switch from console to Windows to ensure the application runs as a Windows application without a console window. Now, let's add the required library dependencies. Before switching back to release mode, temporarily change the configuration to debug mode. Apply the changes and copy the library dependencies you used in debug mode. After copying, switch the configuration back to release, paste the dependencies in the appropriate field, and apply the changes. Click OK to save the settings. Now, build the project in release mode. Once the build is successful, navigate to the release directory. You'll find the executable file there. Notice how compact it is, just 348 kilobytes in size. Run the executable. While the game runs correctly, you might notice that the custom font style isn't loading. This happens because the font file's relative path is just the file name, and the application can't locate it in the release folder. To fix this, copy the font file into the same folder as the executable. Run the application again, and this time, the font style loads correctly. Now our game is fully released and functioning as expected. Thank you for following along with this Tic Tac Toe game tutorial. We've built a complete game interface using Dear ImGui, added dynamic gameplay features, styled it with custom fonts, and even prepared it for release. I hope this project gave you valuable insights into game development and working with Dear ImGui. If you found this tutorial helpful, please give it a thumbs up, drop a comment with your thoughts or questions, and share it with others who might find it useful. Don't forget to subscribe and turn on the notification bell so you never miss out on future tutorials. Thank you for watching, and I'll see you in the next video. Keep coding and stay creative.